before we start talking about stoichiometry, we can discuss conversions that involve the mole. So the abbreviation for mole, M-O-L-E, is M-O-L. We can go from moles to particles. Now, you may not always see the word particles. You may sometimes see atoms or molecules or ions. But by definition of a mole, for every 1 mole, you have 6.02 times 10 to the 23rd things in that mole. So that's called Avogadro's number. Notice also that I did a double arrow here. So if I know how many moles of a substance I have, I can directly get to particles. And if I know how many particles I have, I can directly convert that to moles using dimensional analysis. The other thing I'm sure you're already familiar with is going from moles to mass. Now the units of mass that we typically use are grams. And again, if you have one, you can get to the other. Where you would find this information, there's nothing to memorize here like with Avogadro's number. Where you would find this information is from the periodic table called the molar mass, okay, the number with the decimals. And then finally, we can go from moles to volume. Okay, and that volume is typically going to be in liters. Again, we have a double arrow here. Now, there are 2 different types of volume, or 2 different ways to go from moles to volume or volume to moles that we can discuss. One of those ways is if you have a gas, so specifically a gaseous state of matter, and that gas has to be at standard temperature and pressure. So that would have to be indicated. Then you can say that for every 1 mole of that gas, doesn't matter what gas it is, it's going to occupy 22.4 liters of space. Now, if you have a gas at different conditions, not at standard temperature and pressure, you'd have to do gas laws in addition to stoichiometry, but you could figure out how many liters in 1 mole. That quantity is called the molar volume. The other way you can do it is if you have a solution. So of a solution. And that, of course, is molarity. So big M stands for molar or molarity, and that's defined as moles of your solute in every 1 liter of solution. So if that's given to you, that's your ticket between moles and liters. All of this is great. We haven't actually done any stoichiometry yet because by definition, stoichiometry is starting with 1 substance in a balanced equation. So you always have to start with a balanced equation and going to a different substance. So for example, moles of A, okay, I'm doing all those in green, and then we can go to a different substance, moles of B. So that mole to mole ratio you do using the coefficients in your balanced equation. And that's your only way to have a different substance on the top of the fraction as you have on the bottom when you're doing your dimensional analysis. You can see I filled in the other quantities in the pink. So this would be for substance B, right? So the same thing that I have over here. And here's the cool thing. If you know you're starting with, for example, particles of A, and you want to get to mass of B, you just kind of trace this. So you have to start with particles, you have to get to moles of the same thing. Then you use your mole ratio to get to moles of a different thing. Then you use your molar mass to get to mass of that second substance. So the way I do it, that would be a 4-fraction problem because I always take my given number and I put it over 1, so that counts as the first fraction. Last thing I want to show you, there is a way to directly convert between mass and volume of a substance, but that's only if you know the density. Okay, so if you don't have the density, then you wouldn't be able to do that direct conversion. If you do have the density, then you can absolutely apply that. So hopefully this was a good review of stoichiometry.